So, Assalamu alaikum everyone. I hope you are doing really great and welcome to our very first Sunnat629 Labs podcast under our new KT means Kotlin Adda series. I'm Mohi Sunnat from Sunnat629. Today it's really a proud moment for all of us. This is a big day for all Bangladeshi Kotlin and Android developers and also the communities. For the first time, an engineer from JetBrains, the team behind Kotlin and Compose, are joining as a guest for a session with or for our Bangladeshi community. So, the thing is today's topic is Compose hot reload in Compose, and it's that magical workflow where all the tweaks and your code and instantly see what the changes like the web. And to guide us throughout the whole things, we have someone truly special with us. He's a developer advocate at JetBrains, working on Kotlin Multiplatform and KMP tooling. Sorry, that's a glitch. Okay, so yes, here's the thing. And this guy is also he spent time in the Google as an Android developer relations engineer. He also teaches Kotlin in the Budapest in the university. Budapest University of Technology and Economics since 2007. Please welcome our guest, Márton Braun. Hello Márton, how are you? And how does it feels like to be here with us, for the Bangladeshi Kotlin community?
Hi, I'm doing great, and thank you so much for having me on for a bit of Compose Multiplatform.
Nice. So, yeah, I think I don't know, I think you and we met 4 or 5 years ago in Berlin in 2021 before you were joining in Google, right? So, unfortunately, we didn't have that much connections, but yeah, I hope for the sake of Bangladeshi Kotlin community from now on, we'll stay connected, right?
Yeah, absolutely happy to contribute here.
Yeah, it's really nice to have you. And yeah, so we'll not go that further. So just to a small thing that, of course, Márton will show us regarding the hot reload, and after that we have some questions during this campaign. We got some questions from the communities, and of course he will share his thought about that. And please, for that, just sit back and maybe take some notes if you want for your own project, and of course try to share to your network so that no one miss these opportunities. Yeah, Márton, the floor is yours. So
okay, quick technical check while I get the screen share up. Do you see the stream live on YouTube? Because for me it's not playing yet.
Let me check.
Just to make sure that everything's working.
Okay, yeah. Wow, I think it changes the URL. I don't know why. Yeah. Okay, I can share with you maybe Slack. I need to maybe do something. I don't know why it changes. Can you check?
Oh yeah. I see that it's working.
Okay, nice.
But yes, it did indeed change. So you might need to share it somewhere.
Yeah. Let me just. Then let me give some time. Wow, I don't know why it just changes everything. It's the same.
I guess you can share it in the chat of the previous video.
Yeah. So I'm just
that should work.
Planning. Yeah. Thanks, like I didn't actually notice like it's not working. I hope like yeah, I think like we can continue. I'm start sharing in my other channels. Like, is it okay?
Yeah, yeah.
It will be also recorded. So
of course.
So yeah, please take your time. I'm just leaving here.
Okay, should we get started then? Okay, yeah. So hello everyone. Thanks again for having me here. Happy to present to you about Compose Hot Reload today, which I think is one of the most exciting things that we've built in the last year or so around Compose. And what it allows you to do in a nutshell is make changes to your Compose UI code and then see those changes in a real running application really quickly. And the easiest way to show you what hot reload is like and to explain it is to start with a demo. So I'm just going to hop over to IntelliJ and show you what it's like to use in action before we dive a bit deeper into how it actually works. So for this, I have the Kotlin conf app loaded in IntelliJ. This is one of our primary samples. It's also the actual application every year for Kotlin conf. And it's a Compose multi-platform application which targets Android, iOS, desktop, and web. I also have the Kotlin Multiplatform plugin installed. If we hop over to plugins, you can see that I have the KMP plugin here, which provides tooling support for all kinds of multi-platform things. The important part for us today is going to be that it gives us the tooling support to easily launch something with Compose Hot Reload. So in this case, I am going to launch the desktop version of the Kotlin conf app using the gutter icon and selecting this Compose Hot Reload option there. This is a significant moment during the talk because this is going to be the only time that we actually run the application from scratch. And it started on one of my other screens. So I'll just grab that and pop it over here, which should be visible on the stream as well. This is the Kotlin conf schedule app. So we, of course, have a schedule page. We have speakers. We have a map in there. And we have, for example, this info page. So let's see how we can edit some of our UI and see those changes using Compose Hot Reload. I'm going to clean this up just a tiny bit so that we have a bit more space. And let me find the info screen first. So we'll navigate over to the implementation of this screen that we have open. And let's say that I want to add some more spacing between these items that are on here. So these are arranged with one of these columns like this one. And currently they have this spacing of 8 dps between each of the items. If we want to change this, I can just rewrite the code here, change it to something like 16 dps. And as I save the file, you'll see that hot reload kicks in. It starts recompiling our code. And then in just a second here, it will flash in green, indicating that we have loaded these changes into the app. So without having to rebuild, restart the app, and having to navigate to the screen again, I can see what this new value looks like. And of course, I can play around with other values. So very similarly, if I just iterate on this, try different numbers here, I can see what those different options might look like on the actual UI. We can, of course, do this on other parts of the UI as well. For example, we have this row of social icons down here. If we want to adjust that to match the spacing, change it from like 8 to 12 dps, again, I can change that. And as I save it, you'll see that hot reload kicks in. It recompiles for a second, and then it loads the changes into the app. And all throughout this, the app actually remains interactive. And we have all of the benefits of running a real app. So if we had to sign in, if we had an ongoing session, anything like that, we could keep all of that without having to restart after making our code changes to the UI. But these changes that I made so far are fairly simple. So I was basically just changing constant values. So let's see what else we can do with hot reload. For example, we can make changes to the actual layout. We have some of these social squares here for different platforms. And if I say wanted to remove one of these from the app, you can see that I can make this kind of structural change. Yet again, hot reload can recompile this, load the change, and you can now see that we removed part of our UI. If I wanted to undo that, I can, of course, undo it. Again, save, and hot reload will pop that piece of UI back in. We can also try adding brand new code to our UI. We have this separate component which renders each of these social icons down there. And let's say that instead of just showing the icon for them, I want to have an icon as well as the text, the name of the platform below it. So I can change this function to use a column. And instead of just having an image, I can also put a text in there. And I already have a description as a parameter because we were using that for accessibility. Of course, if I only make these changes, you'll see that my UI probably breaks because all of my styling is not correct now. So I do have to iterate on this a bit. I have to probably move all of these modifiers up to the column. Again, I can save this and almost immediately see what that change looks like. We can see that we still have some problems. For example, we probably want to align everything here horizontally. And also our cards are not large enough to show both the icon and the text. So I can just change that to be maybe like 96 dps. And with that change loaded as well in a second here, we can see that now we can actually fit everything that I wanted on there. And from here, we can keep iterating, right? So we can have maybe a spacer in there, maybe like 8 dps of spacing between the icon and the text. And once again, I can just save this, wait for hot reload to kick in, and now I see the new version of the UI, all without having to restart in the meantime. Now, these were still somewhat limited changes. I only edited the bodies of existing functions, but hot reload is actually very capable and can reload almost any type of code change. So let's say that I want to introduce a new function. For example, take this entire row of social icons and extract that into a new composable. I can also do that. I can use refactoring here. I can call this something like social row. And you can see that as I create this new function and save it, this also reloads correctly. So hot reload actually allows us to change structural things in our code, introduce new functions, change the parameters of functions, and so on. And all of this can be loaded into a live application. Just to show you that we are indeed still looking at the current version of the code, I'll change something like a weight, and then we should see that the middle card here becomes larger than the rest of them, which is pretty nice. We could also look at things like opening one of these links, which I think is going to be on the wrong screen again. So I'll just drag that browser back in here. So as you can see, as I clicked the link for Slack, it actually opens the wrong page. So we have a bug in our code where this link actually takes us to Blue Sky. And if I click on Blue Sky, that actually tries loading up Slack. So these are wired in the wrong way around. So we can perhaps debug that and also fix that with hot reload. I can take a look at where the callbacks are being handled. And I can see that essentially these look correct when the onSlack callback is called. Then we are trying to open the Slack URL, and similarly with Blue Sky. But if I keep navigating in here, we'll find that actually we have these defined the wrong way around. So we just have the wrong constants in the wrong strings. So if I take these and simply swap them, I can also make this kind of change with hot reload. So now if I let that reload, bring the browser back, and now if I click on the Blue Sky icon, you can see that that actually loads Blue Sky correctly, and then Slack is trying to open a Slack client. So even things like these essentially static constants that we have in our code here can be reloaded using compose hot reload without having to rerun the app, which is really, really powerful. We can also hop over to the settings screen perhaps and try to make some changes there to show you some more scenarios where hot reload is especially useful. So one of the things that we have here is a theme switcher. In fact, that's the only thing that we see here because on desktop we have most of our settings hidden by this feature flag in the code because notifications are only available on our mobile targets. But of course, for the sake of this demo here, if I want to look at the rest of the UI, I can just change the value of the feature flag directly here to true, and then I can access those pieces of the UI as well, just during development. The other thing that we have here is this theme switcher, which allows us to switch between light and dark themes. And as you can see, we have a nice little animation here, which vibes between the light and the dark version of the app. And if we want to iterate on this animation, that's also really easy to do with hot reload, because we can really have a feel for the application as it's running, as our changes are applied to it. So for example, if I want it to be a slower animation, I can change one of these values here, wait for hot reload, and as soon as it's done, if I click the theme switcher again, you'll see that now the animation runs a lot more slowly. Or if I want to change the easing curve so that instead of being completely linear, I would want it to be more exciting. I can look at all of the easing options, and I can try maybe one of these in-out options. So like an in-out cubic easing, for example. Once again, I save it. I wait a second for hot reload to happen. And then if I run this again, you can see that now there's kind of a velocity to the animation, right? So it speeds up and then it slows down. So it's a bit more pleasant. Or I know that we have some bouncing animations, for example. So we have like an ease out bounce animation. Yet again, we can try that, wait for it to reload, and immediately click it again and see the bouncing transition between our two different screens. And maybe that's a bit slow. So again, we can iterate on the duration of this. And I think with that, we probably have a pretty decent implementation for that animation now. It's also worth highlighting that as I was trying all of these constants, all of these, of course, have to be imported. So if we scroll back up here, we can see that as I was making those changes, we were also adding new imports to the file, for example. So that's also something that works just fine with hot reload. So you can grab new things from imports, you can start using them, and that can also be loaded into your live application, just like that. So now that we've seen how hot reload works in practice, let's talk a bit about how it all works and what you need to do to set it up. First of all, hot reload is implemented as a Gradle plugin, so you'll need to add the Gradle plugin that you can see on the screen here to your application. You also need to add this line to your settings Gradle file, which sets up a Gradle toolchain resolver convention, and I'll get back to what this does in just a second. And finally, if you haven't been updating your Kotlin versions recently, if you haven't updated it since this summer when Kotlin 2.2 arrived, then you might still want to have this extra option that was required before 2.2. But again, if you have already upgraded to 2.2 or later, you can just forget about this part, and adding hot reload basically is just 2 lines of configuration. So how does hot reload work? Normally, when you launch your application, you build it with your build tool, for example, Gradle. It starts the Java runtime, and then it loads your application's code into that runtime so that the main function can be executed and your window appears and your application is rendered. This start of the Java runtime is the first thing that we intercept and customize, because we want to make sure that the runtime that you're using is the JetBrains runtime. This is a special fork of OpenJDK, and we're using it because it has features that allow us to implement hot reload in it. The way that we can ensure that Gradle can use this Java runtime to launch your app is exactly by that resolver convention. So if you're not using a JetBrains runtime JDK yet, then this convention that we set up in the Gradle project can automatically download it and use it when you launch your app with Compose Hot Reload. So as I mentioned, we're using this runtime because it allows us to use something called DCEVM. And that's going to be the special technology that allows us to redefine classes at runtime as you make code changes and migrate your code from the old version to the new one. We also inject a Java agent into your process. So hot reload also has an agent that lives inside the same process as your actual application and can communicate with your app's code. Once we have this running, we need some other components as well. Namely, we will have a separate supervisor process for hot reload, which is kind of responsible for coordinating all of the different parts of the hot reload technology. And the main thing that it does, that interests us, is that it will launch a recompiler process. We have different ways of triggering recompilation. We have some different modes for hot reload. We have ID integrations, we have file watching with Gradle continuous builds, so you have a couple options of how you want to run it. But the important part is that this supervisor is running a recompilation, which can produce new bytecode. And whenever recompilation happens and that new bytecode is passed back to the supervisor, it will pass it on to the agent and the actual reload will happen. So first we'll invoke DCVM, which will take the all the classes in memory from the old version to the new version. Then we'll do some diffing and figure out which parts of your code you have actually changed, because we need to figure out which parts of your UI were affected by the changes so that we can tell Compose to rerun those composable functions so that the changes are not just loaded into the runtime, but also shown to you visually. So we need to rerun some composables, basically invalidate some of your UI. And once we do this diffing, that's what we do. So we talk to the Compose runtime that's inside your application's runtime. We tell it to drop some of its already rendered subtrees, and that will cause the recomposition to happen and run the new version of the code, showing the updated version of the UI. We do have some other pieces of tooling that also talk to the supervisor. For example, we have some dev tooling, which you actually might have already seen as I was demoing hot reload a second ago. And we have some ID integrations, which again also communicate with the supervisor. Let me talk a bit more about how the reloading part happens. So DCVM stands for Dynamic Code Evolution Virtual Machine, which is quite a mouthful. This is basically a proposal of doing advanced redefinition of classes at runtime on a JVM. And the JetBrains runtime just happens to be the only version of OpenJDK that implements it, which is why we're using that specific runtime. The way that this works is that you have your current class loader that contains the current version of the classes in your application. For example, I have this simple offset class here with just single property in it. And when you receive new bytecode and you want to load the new version of classes into the app, those classes will be loaded into a side universe class loader. All of the existing instances of offset in this case that are already in memory will be migrated from the old version to the new version. And once that's done, the side universe class loader simply becomes the primary class loader, and the execution of your application continues from there. Let me show you a more visual example of what that migrating part actually looks like, because it's not trivial that we can take existing objects that are already in memory and we can change their structure. So how do we do that with DCVM? Again, let's stick with this example of an offset class, and let's say that we have a couple of instances of it already in memory. So we can imagine that these would sit somewhere in the heap. They would all have the object header that every object on the JVM has, and they would also have the space in memory where they store their actual values. Because we're storing just a primitive int here, it would be the actual value of the int that's stored there in memory. In order to add a new field to this class, we'll need to allocate new memory for each of these instances. So we'll go ahead and allocate some new memory for each of those offsets that are already in the memory. And for the fields that already existed, as well as the header of the class, we can simply copy the existing values over to the new space that we allocated. And then we'll have the space that is the that's there to make space for the new property that we added, that y property up there. And new properties like this, we just have to initialize to some kind of value. And the way that we do this is that we use the JVM defaults in this case. So for numerical types, these would be just zeros. For reference types, we would have to initialize them to nulls. For Booleans, it would be false, and so on. And once we have these new versions of each of the offset objects, we can simply drop the old versions and continue executing the code from here. If you think about it, what we're doing in this case is basically a special garbage collection pass, because we're pausing the application for a very brief moment. We're moving some existing objects to new locations within the memory, and then we can resume executing the app. So we're kind of just performing a garbage collection here, but we are also changing the structure of classes potentially as that's happening. So once we have all of the classes changed and the bodies of functions reloaded across the old and the new version, as you have made your code changes, we also need to invalidate some of the Compose UI, as I mentioned. So for this, we need to do some intelligent diffing of which part of the Compose code has changed exactly. For this, we maintain complex structures in the background, and I'll reference a talk at the end of this one that you can check out if you want to learn the details of that. But essentially, we keep track of the contents of every group and every function that's used in your Compose code, and we can detect changes in the bytecode of each of those different composable groups. Here we have a small example where we have a function that just returns a 16 dB value, and then we have a simple counter implemented in Compose. So we have a piece of state, we have a card, we have a button on it, and tapping the button just counts upwards. Let's say that I change the value that the medium padding function returns. As I mentioned, we would be able to detect this because we monitor the hashes of the bytecode contents of each of the functions. So we would know that it was this function that was changed during the reload. We also keep track of the usages of each of these functions. So we can follow this and see that it was used as padding on that button that's nested inside our card. So we would follow this, and then we would find the closest group in Compose that we can invalidate and drop the state of. In that case, in the case of this example, that would be the entire card. So we could invalidate the contents of the card, which would cause the entire code of the card to run again, call the medium padding function again as it runs, receive the new value, and you would see the larger padding appear on the screen. As this reload happens importantly, because we're only reloading the contents of the card, the state that we have declared for the counter here would be preserved. So we try to preserve as much state as possible with Compose hot reload, but we also always want to make sure that you are seeing the latest version of your changes. So if we have to choose between dropping some state and showing you the correct UI that matches the code that you just wrote, we always want to make sure that you see the correct UI first. And if we have to drop some state, we'll do it when it's required. For example, if we went back to this sample here, and we changed some of the text that's rendered here using the text composable, this text change would only be reloaded by invalidating the entire body of the function, because that's the closest group that we can clear. So in this case, to show the new version of the text, we would have to drop that mutable state as well, so our counter would reset to 0, but we would see the new version of the text on the UI. With that bit of deep dive into how hot reload actually works, let me get back to the demo and show you some more interesting and exciting things that hot reload is capable of. Let's go to the speaker screen next, and let's say that we want to search for all of the speakers from KotlinConf that were called Sebastians. Here we can again iterate on the UI that we see on this screen. For example, I know that each of these cards is rendered by something called a speaker card in the project. And we can play around with how that card is displayed. For example, we can try different sizes of the avatars. So right now we have 96 dp set up here. We can also try maybe 48, maybe see what the screen would look like if we used much smaller avatars, something like this. Or we can hop even into the speaker avatar function, and instead of having a rounded shape for them, we can check out what the UI would feel like if we had circle shapes for each of these. So once again, as I save all of these changes, hot reload kicks in. Hot reload kicks in each time, and it shows us the change in real time inside our application. And also, it preserves our navigation state and even the current search that I've put in there. What's slightly more interesting about these changes than the ones that we were making before is that I'm actually doing this in a multi-module project, and these components that I'm changing inside the screen are actually in a separate module from the application itself. So these are inside the separate UI components module, all of these like speaker card implementations, and our application lives in the shared module. So Compose Hot Reload also works fine if you have your code base modularized and can even reload across module boundaries like this. While we are here, we can also try resizing the app, for example, and we'll see that it's not a very responsive UI. We have this fixed 2-column UI set up at the moment. And we can, of course, also change this using hot reload. So if we go to the speaker screen where this is implemented, I expect that this is some kind of grid. And we can see that indeed it's a fixed 2-column grid. So we can, first of all, play around again with simple changes. We can see what this would look like as a single column grid. So basically what this would look like as a list view. But if we want some responsive UI, we can also try different grid style configurations, for example. So let's say that we want to see what it looks like if we have an adaptive grid, which gives each speaker 200 dps of space. So once again, we can try resizing. And now that we have an adaptive grid, we have this nice dynamic behavior. Maybe we can search for something that has more results, like look at all the JetBrains speakers at the conference, and then we can see how this UI works as we're resizing with a lot of items. And maybe 250 is not quite enough because these are a bit narrow. Again, it's really, really easy to get a good feel for the application and iterate on it. I can change it to something like 250, and that probably looks correct. Something that I didn't show you yet is what happens when there's a compilation error. In this case, hot reload will again try loading, but show you this red UI, which shows you that your code is currently red. So you should go ahead and fix it before the changes can be loaded. If we open the run window, we can actually check out some of the related ID tooling here. So first of all, as you're running your application, you have your main logs where all of your application logs would appear. And we also inject the status of Compose Hot Reload here. So you can see the build messages coming from each of the reloads that are executed right here. And this also lets you navigate to things like errors. So if you fail to reload for some reason, you can just click on the error message and it will take you to the exact place in your code where you have your problems. Of course, in this case, it's that missing parentheses that I had. And if I just go ahead and save this, you can see that we can actually recover from this just fine. So we're back into a green state. And once again, if I don't know, change something here, you can see that we can continue reloading and seeing the latest changes inside our app. All right. So I think there's one more thing that I wanted to show you when it comes to these demos, which is that the changes that we make with Compose Hot Reload are not necessarily limited to making UI changes. If you want, you can actually change any part of your application code with Hot Reload. It's just that in the case of Compose UI, we can figure out automatically what parts of your code we have to rerun, and we can talk to the runtime so that the UI is actually re-executed and rendered using the new version of the code. But if you make changes to other classes, those changes will also actually work, as long as you can somehow rerun them. So let's hop over to the schedule screen. Let me show it in the application first. So the schedule screen is, of course, a long list of the sessions at the conference. And we have a button here that lets us filter the schedule screen. to only show the sessions that we have bookmarked. So instead of having all of the sessions here, we can see that we have those that we have marked with this little bookmark. And for any of the slots where we don't have anything bookmarked, we kind of just have this empty looking slot, which is not ideal. Maybe we want to do something about that and add some new entries into our UI that just say no bookmarks here or something like that. The way that this screen works is that the entire thing is implemented with one huge lazy list, and the items in here, all of these labels and all of the different titles, are all parts of this seal type, which is called schedule list item. So to add this new item, all I have to do is add a new entry to this seal type, which of course is not going to compile because we have usages of this seal type somewhere. And I've also prepared some of the logic somewhere in this file, which just checks if one of the sessions was empty and we're currently in the filtered mode. And if that's the case, it adds that new item into the list. Now if I save this, it still won't compile because again, we have some usages of this seal type somewhere, but I can just go ahead and hope to the error message from the logs, and it will show me that, of course, it's the schedule screen class, which is using the view model. So if I add all of the remaining branches in here, for example, by filling out this ID generation and then this other when statement, which is responsible for actually rendering each of the items that are in the big list, then I can add some kind of UI representation for the new items that we're now generating, like no bookmarks here or something like that. And now that our code is in the green again, we'll see that hot reload happens, and we have actually successfully hot reloaded, but we don't see the change because the code that we modified on the view model side, where we added new logic, is just some function of some class in our code. It's a private function inside the view model, and the way that it's executed is inside this flow combine statement. So if one of these incoming values from the different flows that are being observed changes, combine will run again. It will call into this function and it will build the new version of the schedule item list. So this is something that's really just arbitrary code somewhere in the business logic of our application. So hot reload has no way of rerunning this function. It wouldn't know how to run it, what parameters to pass in. So we can't do the kind of invalidation that we are able to do when it's code that's inside your Compose UI. However, we did load the new version of that function. So if we can somehow trigger this function running again, then we will actually be running the new version of it. And there's actually a really easy way to do that because I can just change the search parameters and that will re-render the UI for us or rerun the function inside the view model. So if I just toggle the bookmark filter on and off here, you'll see that now we have actually added these new items that I implemented using Compose hot reload, and they actually appear on the UI. And from here, making them look nice is just a bit of tweaking, right? So if I wanted to maybe add some padding on there, it probably needs like 12 dps of horizontal padding and maybe some color. We have some constants for this, so I can grab Kotlin conf colors, and this is not that important, so it's probably secondary text. And I think I have a formatting problem. There we go, extra parentheses. So I can make some styling changes like this. And because this is a change that's only within your UI code, we can have hot reload automatically rerun that for you. And we can see that the changes can be reloaded like that live. So as we were doing this, we didn't just change the UI code, we could also change business logic. We managed to rerun it somehow by just triggering that code again. And we also did things like introducing a new class. And not only was it a brand new class, it was a class that we inserted into a sealed hierarchy. So you can see that hot reload is quite powerful and it can really reload just about any change that you're making to your code. And you really don't have to think you don't have to think more about how you're coding them before. So you can just write your code as you used to write it. You can even implement entire features if you want to without restarting your app, and hot reload will take care of showing you the actual changes. What I forgot to show you until now is the little tooling widget here for hot reload. So if I wiggle this window a bit, you'll see that we have that little widget on the side which is chasing it around. So that's also for Compose hot reload. First of all, it's indicating that you have it enabled. It also shows you the number of successful reloads. We can see that I reloaded 28 times now during this talk without having to rerun the app and then navigate back to the screen that I was on. And if we click this, it also opens a window where it shows you some actions that you can use with hot reload. So if you ever want to trigger a manual reload, or if you need to clear the UI state entirely, we have some debugging options like this. And you can also just see the logs here as well. But over time, we're trying to move away from this dedicated window here and move most of this UI into the IDE. You've already seen that the logs are, of course, exposed as logs right in here, so they're easy to copy, and things like navigating to errors and warnings just works as it always does with IntelliJ. And we actually also have the reload state here exposed for you inside the IDE. So you can see that this small floating widget up here is indicating that hot reload is functioning. And we also have some actions here. So if I, again, want to trigger a manual reload at any point for some reason, I can do that using that in there. And if I make, again, just some kind of change to the UI, you'll also see that the IDE tooling also shows the reload as it's happening, and then it goes green when the reload was successful. Okay, so I think with that, we've covered everything that I wanted to demo. So let me get back to the slides and wrap up here. So first of all, if you want to check out hot reload, it's open source. It's a project on GitHub. You can hop over to jb.gg/chr for Compose hot reload, and you can get set up with the plugin using the instructions in the README. Now, one caveat with hot reload is that, as I already mentioned several times, this is using the desktop version of a Compose multi-platform application. And it uses the JetBrains runtime specifically to be able to do this kind of very dynamic reloading of almost any change that you make to your source files. So you will need a desktop target to be able to make use of Compose hot reload. Let's talk a bit about how you might be able to do that. Let's say that you already have an application that's a multi-platform Compose app between Android and iOS, and you're sharing all of the layers of the application. So you have a shared data layer, view models, and UI as well. One of the ways that you could add a desktop app here is by just extending all of these layers to the desktop application as well. So you could have a full implementation of your application with all of the features, all of the real data handling, databases, networking, and so on, running on desktop as well. This is what we have in the case of the Kotlin Conf app, right? It's just the full app running on desktop instead of on mobile. But there are apps where this might not be feasible. You might have a lot of integrations that are specific to each platform on mobile, and you don't really have equivalents for desktop, or you don't want to write the code to build those things properly. So something that you can consider is you can consider faking some of the lower layers of your desktop app. So if you have Bluetooth handling, if you have some kind of native APIs for acceleration, for some kind of sensors on mobile, you could just have a completely fake or empty implementation for desktop and still be able to launch your app, navigate through the UI, and edit it using Compose hot reload, which could be, again, super useful. Or you could have an app which doesn't necessarily resemble your normal application. So it might not use your data layer or even your view models. It might just be some kind of Compose app with an entry point that uses your components from your design system and just throws them into one big list on desktop or something like that. So some kind of gallery-like setup. And you could also use that for your hot reload-based development. It doesn't have to be a real app. As long as you can power your components on desktop and load them into a window, you can use hot reload with that. Something interesting is that we also use hot reload in-house. So for example, we have a Compose desktop app ourselves, which is JetBrains Toolbox, which is the app where you can manage all of your different installations of JetBrains IDEs, as well as Android Studio, of course. So we have hot reload working, for example, for JetBrains Toolbox. So you can see here as we're editing the code base of that application, we can see live changes inside Toolbox, which does say a lot because while it is just a Compose desktop application, it's also a quite complex one. So it's really cool that hot reload is able to support that for us. And then you remember that I showed you all of those different components of hot reload working together. That kind of flexibility also means that we can use it not just for standalone desktop apps, but also when Compose is running in a different context on desktop. Namely, we can use it when developing UI for IntelliJ itself. So on the bottom here, we have that light themed IntelliJ idea, which has the code base of IntelliJ itself open. And then that's running the IntelliJ that's on the top of the screen in debug mode, basically just as a local build. So on the bottom, we have UI that's implemented in Compose that we can edit. And that Compose UI is being rendered in a panel inside the IntelliJ on top. And for something like plugin development, this is actually super, super useful because we don't have to rebuild IntelliJ and relaunch it and open a project in it and so on, and then look at the plugin. But instead, we can just edit the code of some UI in IntelliJ like this. And you can see that the changes just show up essentially in real time using Compose hot reload. So again, a really powerful use case. I think that's everything that I wanted to cover today. Thank you so much for tuning in for a bit of Compose hot reload. In terms of resources, again, you can find Compose hot reload on GitHub. If you want to try it, you can try the samples that are in there in the repository. We also have the Kotlin Conf app, of course, configured with Compose hot reload. So if you want to try it in a larger real application, you can also see that repo for more. And then we have some official content from Sebastian Selmayr, who's the main author of hot reload, where he covers some of the implementation details and tells the story of how this was all built in much greater detail than I could. So there's a great Kotlin Conf talk from him, and he also created some interesting content on YouTube as well as on his blog that you can check out. And I think that's everything. So I think we can basically go to questions if we have any.
Hi. Yeah, thank you so much, Martin. And unfortunately, I'm really sorry regarding this technical glitch. I don't know why it happened, and it just to create a new live streaming without and by default it just enabled the kids mode, and it disabled the live, what it calls the chat or something like this. So some people are asking, and then I suddenly saw yeah, it could be disabled. But yeah, let's see. I hope for now we have already a chunk of questions, so maybe we can go with that. But before that, of course, thank you so much about your presentation. We have learned a lot of things, and one thing I really like that cyberpunk style glitch. So is it a real glitch or any style of hot reload? What is it actually?
Oh yeah, the glitch animation I think is controversial. Some people really like it, some people don't like it. It's implemented, I think, with shaders in Compose.
So just asking about is it impact on the PC or other app? Was there any issue because of this glitch, or it just a style?
Oh no! It's just a visual animation
okay.
on top of your app. So it's just the indicator of hot reload rendered in Compose.
Okay, nice. Okay, just saying whoever actually watching this video, that you can maybe refresh your page and you will see that the chat is enabled. I'm extremely sorry, because by default the service, whatever we're actually using, it by default it disable the chat, and also like it creates a new link. I don't know why, but yeah, okay, thank you so much again. And let's have, like, during this time, of course, like as I mentioned, like we had some already some questions from the communities, and let's hear about your thought. So first of all, like I think like it's kind of the common question for all, like how close is the compose hot reload to be stable version 1 release, so that like like developers are confidently rely on this day by day.
Yeah, so the good thing about compose hot reload is that it's only used during development time, so it doesn't affect your production applications at all. So it doesn't really matter what version it is, or like how stable it is, because again, it will never break your production apps. That being said, it is already almost 1.0. You saw the version on the slides that I updated maybe half an hour ago in there. So it's 1.0 RC2 at the moment, which is essentially the stable build. We are waiting for the next release of Compose Multiplatform, so the 1.10 stable release, because with hot reload stabilizing, we are also going to start bundling it into Compose Multiplatform by default. So we want to make sure that it's easier to get started with it, so that you won't have to add the plugin in the future separately, but it will be included with just Compose Multiplatform.
Nice, thank you. And the second one is, right now, like as you mentioned, like it's working on desktop. Then what would be the plan for the iOS or maybe non-JVM platform? Like,
yeah, so the way that hot reload was built and the way that it works using things like DCVM, it's very strictly tied to the current implementation on desktop. Of course, we do have ideas of bringing it elsewhere, hopefully. We are experimenting with some things to see how native code can be reloaded, so to see if iOS would be possible. Of course, it's a lot harder to reload code without a virtual machine. So we need completely different techniques, but we are investigating and experimenting and seeing if it's possible. And of course, it will have to work probably just as well as on desktop if we're going to do it. So we want to make sure that we can really reload a lot of changes, that we don't need to force restrictions on you about how you can change your code. We want to make sure that it's reliable, just like on desktop. But we're looking into it. And then for the Android part, we'll probably also investigate that when we have time. But I would also recommend asking Google for like more support on the Android side, because ultimately they do own most of the tooling and the platform. And they have had things in the past, right? Like such as Live Edit. So it would be, it's probably worth asking Google to see if they can contribute on the Android side.
Okay, sure. Maybe we'll ask somehow, like to the Google. Okay, then here's the next one regarding related to the Android Studio. Maybe it's kind of similar, that we have already there's a feature in the Android Studio that the live edit inside, right? So how does that fit with this hot reload? Are they like separate things, or they're moving to the same way?
They are fairly separate. There are some things that both of them use, and as hot reload was developed, we actually had to make some upstream changes, like some changes in the Compose compiler to make sure that it works better, and Live Edit can probably benefit from those changes as well, so be more reliable. But Live Edit works very differently overall, and because it works differently, it has very different limitations. So as far as I remember, you can only edit the existing bodies of functions, for example. So you cannot introduce new functions or new classes at runtime with Live Edit.
I think there's a glitch. Can you hear me?
Yeah, I can hear you.
Okay.
All good on my side.
Okay. Yeah. Sorry, like maybe then myself. Okay, thank you so much. And the other thing is, as a like from a developer's point of view, like does hot reload actually preserve all the UI state like during the edit, or just it lost some parts of like UI tree?
Yeah. So the parts of the UI that you have changed, like the immediate part of the UI that you've changed, we do have to drop the state in that part of the compose tree so that we can invalidate and make sure that it runs again and it renders valid UI. But we try to invalidate the smallest possible scope always. So we try to clear as little state as possible and preserve state where we're able to. But it's always correctness that we go for first. So if we have to drop some more state to make sure that you are seeing the correct UI, then we'll drop the state in order to show you that. Basically, we don't want you to be in a state where you have made a change. You see some of the change on the UI, but you're not sure if you're seeing the correct UI or not, and you're thinking like, should I just close the app and restart it to see the correct change? So we don't want to have like a half broken state ever with hot reload. And so for this, we need to clear some state sometimes. And this is probably one of those things that we are going to be able to improve after 1.0. So after we've stabilized the basics, we'll look at some specific cases and see if we can preserve more state, if we can have more intelligent tracking of what needs to be reset and what can be kept.
Wow, nice. So the next one is like under the hood, like how much of hot reload depends on the compose compile versus like maybe time instrumentation, like where the most of the magic is happening.
I would say it's basically all runtime. So compilation for anything that you're reloading just happens as usual. So we run the build tool, for example, Gradle. It gives us new bytecode, and then the magic happens at runtime, because that's where we do the patching of the bytecode, loading new versions of classes, and then all of the diffing and the tracking. So basically, it's all runtime instrumentation of your app.
Mm-hmm. Nice. So how about I mean, like it's kind of not directly the hot reload, it's based on the compose. So how does compose for iOS render the UI now? Is it still using Skiko, or like there is a new rendering pipeline?
Yeah, it's indeed all Skiko. So Skiko is our Kotlin Multiplatform wrapper around Skia, and Skia is the rendering engine that we use on every platform. Just like Jetpack Compose uses originally on Android, we're using the same Skia engine on iOS, web, and desktop as well for Compose Multiplatform. And essentially, we never had issues with Skia so far. We are hitting all of the performance targets that we have. And I mean, Skia is everywhere, right? So it's used to render in Chrome. Mm-hmm. It's used as Android's renderer, both in Compose and for System UI and for Views. So we're quite happy with Skia so far. That's not to say that we'll never change the renderer, but so far we didn't really have a reason to move away from it.
Oh, nice. So there's some question from our live chat. So one guy is asking, like, could you let know how it's for applying the changes related to the BL instead of the UI? I don't know what the BL means. Can you explain maybe? And also
business logic, I assume.
Okay then. Mm-hmm. And also, like it said, is there any common known edge cases are not supported now, even for the UI as well?
Yeah, so for the business logic part, basically, if you're making changes to your code that's not being rendered as part of Compose, so that's not part of your Compose view tree, then we're not able to rerun that code automatically because we don't have the context of what and how we would need to re-execute. But if it's something like a button's click listener, say, then if you change the logic of the click listener and then you click the button again, it will run the new version of the code. So you can reload any kind of change. You can, you just have to figure out how to rerun that. So if it's inside some kind of, I don't know, like database handling code or whatever it might be, if you can rerun that by navigating to a screen or pressing a button in your app, then it will run the new version of that code after it's reloaded. But of course, we are primarily focused on iterating on UI because there you get the full magical experience where you change your code and we can actually rerun the UI code for you and you can see the change immediately.
Wow. So till now, yeah, there's another one, but it's already the similar about he was asking about like it's similar to live edit. So yeah, I think like you got your answer. So yeah, till now like we had this type of this amount of questions, and yeah, I think like it's kind of our last part of our session. And honestly, as far as I understand, like next time maybe we will do during the weekend. I mean, like it's true, especially like in our country. Like I don't know, like if you have any experience, like in our country, normally, let's say we have in the capital of Dhaka, it has a massive like a lot of traffic jam. So normally when I was in Bangladesh and after work, it took at least like 2.5 hours from my office to go home, and it was total jam. And during this time, it's kind of middle of a lot of people are either they came to the office from the office or maybe middle of the way. So yeah, maybe we'll try something middle of or the weekend night or something like this. So there will be a lot of people, and of course I know like who will watch this video, they will have some other questions. So maybe I will read to you a little bit so that if you have some time to answer these questions.
Yeah. On the bright side, anyone can catch up on the recordings.
Yeah, sure, of course. So yes, thank you so much, Márton, again, and we're really like happy to have you. And it's kind of like a good chapter for Android and Kotlin community in our country. And yes, it was really impressive. Now, okay. So can you do you have anything for related to the compose or anything for us like before you go, or say something for us like like the community?
I probably just want everyone to try hot reload, see how it works, try playing with it again, like whether it's in your app or you can just grab the Kotlin Conf app, which is already there, and let us know how it is. Again, we're very confident with it at this point. It's essentially stable, but still feedback is always welcome, especially on things like the UX around it. Mm-hmm. And the newer version of IntelliJ, you're using the better tooling you'll get, because we're definitely still working on the ID integrations. And other than that, yeah, thanks to everyone who tuned in. Thanks to everyone who's catching the recording. And I hope you learned something today.
Yeah, sure. So the thing is, as you also know, like in our country, normally we had some related to the KT Adda, and we will actually continue through this conversation, maybe with another global or local experts. And yes, if you're experimenting with anything Compose Multiplatform or Hot Reload, please try to share with us, maybe tag our communities, and yeah, of course. So I think thank you so much, and I hope like a very good and have a nice day, rest of the days then. Thank you, Márton, and everyone, thank you so much, and see you in our next session. Goodbye.
Bye.